All right, so we're going to talk about rates and unit rates, which is going to kind of pull together the things we did last week and make this relevant and applicable to the things that you will see in your life. It's not too confusing. It's going to use a lot of what we've done. So let's start off with the definition for rate here. Don't need to worry about these things. But a rate is a ratio of two quantities using different units. It's a ratio of two quantities using different units. So when we think about what that means, a common one that we come across is MPH, miles per hour, right? So we have two different quantities. So if we're going like 60 miles per hour, we're comparing 60 miles per 1 hour. And when we think about unit rates, which is the next thing we're going to write down, we are thinking about rates as compared to 1 unit. So a unit rate compares a quantity to 1 unit of another quantity. Again, so thinking about miles per hour, we're comparing the quantity of one thing to 1 unit of another quantity. And when we think about equivalent rates, that means that they have the same unit rate. So when I talk about a unit rate, this is the easiest example I could think of. So if you're ordering 3 pizzas, right, and you pay $27 for 3 pizzas, the unit rate would be to split the cost by the number of pizzas. So it will always tell you, or typically, if it doesn't tell you, you can assume the unit rate we're looking for is whatever the second part of the ratio is. So the unit rate here would be, it would be $9 per pizza, right? So we split the 27 into 3. 27 divided by 3, unit rate there would be $9 per pizza. So for an additional example, and I'll walk through this one, we have this question. You make fruit juice by adding 4 pints of water for every 2 cups of concentrate. And for those of you that aren't familiar with what concentrate is, that is where you have like a focused amount of a flavor. The most common one I can think of is, you know, those like little pouches that you pour the powder into your drink and you shake it, and you've got like Crystal Light or Kool-Aid or things like that. That powder is concentrate, right? If you just put that directly on your tongue, it'd be really strong flavor because it's kind of focused flavoring. So for this, it says we're making fruit juice by adding 4 pints of water for every 2 cups of concentrate. So it says find the unit rate. What we're going to do for that is set up this ratio table. Right, so we have 4 pints of water, 2 cups of concentrate. And if I want to find the unit rate, so how many pints of water per cup of concentrate, I'm simply, and this is a basic example, but just to get the point across, if I want to find out how many pints are in 1 cup of concentrate, I need to go from 2 to 1. And how do I go from 2 to 1? Remember, it's always multiplication and division. I would divide by 2, meaning I have to match that up here and divide by 2. So I would have 2 pints of water per cup of concentrate. Notice I'm not necessarily saying per 1 cup. If I just say per cup, that implies that we're talking about 1. So the unit rate here would be 2 pints of water per cup of concentrate. That's the unit rate, okay? And that's pretty basic because it's relatively easy math. We will get into a few more complicated things. Now here, let's say I wanted to find the ratio of cups of concentrate to pints of water, and I want the unit rate for that. So I want to know how many cups of concentrate are in 1 pint of water. Well, how do I go from 4 to 1? Divide by 4. So then I'm going to do the same thing to the top. I'm going to divide by 4. Now, in the last class and in previous years, I've found that no matter how many times we've talked about it, you still see a smaller number divided by a larger number and you panic. But 2 divided by 4, well, I can write that as a fraction, can't I? What would 2 divided by 4 be as a fraction? Step back from that one. Let's not jump to that quite yet. I can write any division sentence as a fraction by putting it like this, right? 2/4 is the same as 2 divided by 4. And then we all know that we can simplify 2/4 and it becomes 1/2. So there's 1/2 cup of concentrate per pint of water. You make fruit juice by adding 4 pints of water for every 3 cups of concentrate. So if we're finding the unit rate here, 4 pints of water, 3 cups of concentrate, I want to go to 1 cup of concentrate, so I divide by 3, meaning I'm going to do the same thing up here. So what do I end up getting?
1/3.
Well, I'm dividing 4 by 3. So again, fraction would look like this. 4 divided by 3, which we could write as 1 and 1/3. 1/3. We're dealing with thirds. So we're going to make 1 whole with 1/3 left over. All right, so here we have a question. A piece of space junk travels 5 miles every 6 seconds. How far does the space junk travel in 30 seconds? Is our first question. Then our second question is, how many seconds does it take for the space junk to travel 2 miles? So the first part of this question is not too bad. We have that it goes 5 miles in 6 seconds. And we want to know how far does the space junk travel in 30 seconds? Well, we have 2 different ways to do this. I'm going to do it the more complicated way first, and then I'm going to show you the easier way. First, we could find the unit rate. We could see how far is it going every second, right? So if I wanted to take this down to 1 second, I would divide by 6, which means I would do the same thing up here. 5 divided by 6, we can write that as a fraction, 5/6. And then I want to know, my original question was how many in 30 seconds. So we can do times 30. Right, and we do 5/6 times 30. Put it over 1. Does this all sound familiar? I'm going to cross cancel here. I'm going to make this super complicated. I did that wrong, didn't I? That would be 5. So it'd be 5 times 5. So it'd be 25 miles, right? Or the way we've talked about in the past.
What would you put in the?
I'll show you. We could say, if I wanted to get to 30 seconds, how do I get from 6 to 30? So then I'm going to do the same thing up here. So that one's pretty basic. We've done stuff like that before, where we just kind of move along the ratio table. Here is where we get a bit more complicated. Here we have a question that says, how many seconds does it take the space junk to travel 2 miles? So I want to go to 2 miles. Let me change where I position that, and I'll show you why. I want that to see 2 miles. Going from 5 to 2 is a little bit harder, isn't it?
Yeah.
So in this case, it would be easier to go to 1 first. Let's see how many seconds it takes to go 1 mile. Well, to do that, I would divide by 5. So I'm going to divide by 5 here as well. 6 divided by 5 would be 6/5. I'm going to leave it as an improper fraction because I'm going to multiply it here in a second. So it'd be 6/5. Then I can do the times 2. And doing 6/5 times 2. Well, 6 times 2 is 12. Oops, 12. 5 times 1 is 5. 12/5. How would I write that as a mixed number? Allie? 2 and 2/5. Right? I can make 2 groups of 5, and I have 2 left over. 2 and 2/5. What you're going to be doing today and with these unit rates is going to be a lot of fractional stuff, a lot of fraction multiplication, which isn't too bad. I'm not going to do any more with that. I'll get your question in just a second. Let me finish this recording. So I was really aggressive with slides this day. I made like 152 slides. Not fun. This will be on the harder end, and I actually don't think you get a question like this tomorrow or today, but you will tomorrow. So I want to look at it. You buy 2 pounds of salmon fillets at store A for $21.50. Your friend buys 3 pounds of salmon fillets at store B for $33.75. How much less would you spend for 5 pounds of salmon fillets at the store with a better deal? This is where we get into that like real life stuff. I talked to the last class, and I want you to look for this next time you go to the grocery store. And some of you have probably seen it. Maya, we've talked about it when we talked about cereal once before. But you know when you go to the store and you've got cereal boxes, you've got like the family size, you've got the middle box, and you usually have like a smaller box, you know. And you'll notice that the smallest one, let's say, is like $3. The middle size box is $4, and then the big box is $5. Okay. The other thing on the tag, and they're legally obligated to put this, is something called is a unit rate. So if you look at the price tag next time you're at the store, you'll notice they have a unit rate. And that's cereal or other things that are measured by weight, not by liquid weight, but by like poundage, would be price per ounce. So let's say the smallest box of cereal is like 50 cents per ounce. So they've taken the cost and divided by how many ounces there are. And then the middle box is like 45 cents per ounce. And then the biggest one is 40 cents per ounce. You'll typically notice that the more you buy, the lower that cost per ounce is, because you're paying a higher cost up front. But this is an example of where you see it. You go to the deli, right, and you're buying like a pound of turkey. It's all priced out per pound, okay? So here, we buy 2 pounds of salmon for $21.50. So how do we figure out the unit rate for this? What would we do? We take the cost of the 2 and we split it by 2 to figure out how much each pound would cost. And at that point, we're pretty good, right? 2 goes into 2 one time. Does 2 go into 1? No, it goes in 0 times. We struggled with this on the last test. We have to represent that. It goes in 0 times. Then we drop down to 5. It goes in 7 times. Bring down 0. 2 goes into 10 5 times. And then our decimal. I know you can't really see that, but it says $10.75. And then the store B is $33.75 for 3 pounds. Bring down to 7. 3 goes into 7 twice. That's 6. 1, bring down the 5. 3 goes into 15 5 times. So that one's $11.25 per pound. So who has a better deal?
A.
Store A. We're dealing with money, so we want the lower number, $10.75. All right.
Can you obviously just tell them?